Hello, my name is Andrew Erickson, and I'm an applications engineer at DPS Telecom. And today I want to talk to you about how you can save millions with superior remote site monitoring. Now, millions, that's a big number, but you might be surprised how much you can actually save even if you're not that big of an organization. But if we fall short here and you only save a couple $100,000, that'll probably still be a good thing. So let's take a look at some of this. To start off, who am I? I've been with DPS Telecom for 12 years. We're a remote monitoring manufacturer, so I deal with this kind of stuff on a daily basis. So I'm hoping I can share some insight from the different industries that we serve. And I'm going to pull from a lot of different sources here, but no matter what industry you are in, if you're watching this video, you're probably in the business of managing a telecom network at some kind of organization like one listed here. Whether it's telecom, if you're a phone company or a TV provider or an ISP, or whether you're in a utility like power, oil, or gas, whether you work for a railroad, you might be in police and fire, 911 safety type applications, managing a radio network, or you could be working for the government or on some kind of a military project. And there are a lot of odds and ends projects as well. We have some farmers and other industries that will use our product too. So even if you aren't listed here, you should keep listening because a lot of this is pretty universal. So really, why is monitoring so important? These are some of the things we hear from our clients. We have a lot of unmanned locations, so you don't have somebody out there. You need to have some eyes and ears out there all the time, but you just don't have a person there most of the time. We need to have visibility of all our field equipment, and that's another key point. You need to see everything. It's not just enough to monitor a little bit and sort of what the quote-unquote important things are. You need to see just about everything, so we'll talk a bit about that. And at some of our service territories where our clients work, it can take 3 or 4 hours to get there, and it gets snowed in. We have a lot of mountaintop sites where even if the general climate in the surrounding area isn't covered in snow, in the winter you're going to start to see a lot of mountaintops that are just snowed in, and it takes a snowcat or helicopter to get up there. It gets very expensive very quickly. So having remote monitoring and control capability becomes even more important in those cases. So some questions to start us off. Does this sound like you? The way I found out something went down was I got a phone call, and I had lots of them. That's the worst nightmare, where your clients, whether they're internal or your actual customers, whoever you're serving with your network, is complaining that things are down. That's obviously the last thing you want to happen. You want to know about things immediately and be able to turn them around before anyone else notices. You might also be saying it was a very crude form of monitoring. So maybe you have something right now, but it's just not very elegant. It's not very well put together. Also, on the snow topic, we get a lot of winter storms, and a lot of our sites are 30 miles from us, and frankly, that's actually pretty close compared to a lot of our clients. If we lost visibility, the only thing we could assume is that the power was cut to the building. We didn't know the voltage on the batteries or if our generator was running. So obviously, this is a case when they have to rush out to a site because they don't know what's going on. It might not be that big a deal. Maybe it could wait till morning, for example, but they just don't know. So when you don't have intelligence, you just have to race around and hope, and it's just not a very good way to be. Another one of my favorite examples, someone actually told me this at a trade show, the slow invisible failure, I call it. So they had a situation where they lost power at a site, and that isn't unheard of. Clearly they have generators and batteries to handle that kind of thing. But then the generator ran for 5 days straight, and it burned through all its fuel. And again, there would have been plenty of time to respond to this, but they didn't know that it was happening. And then the batteries ran for 8 hours because they had 8 hours of life, and they had been fully charged by the generator. That all happened. And then they lost the site almost a week after they initially lost commercial power. And that was bad enough, but then eventually, if you lose focus and you don't solve it right away, it's going to happen again. And that's what happened. It happened again. And so then they called us up and they said, okay, let's get this thing done. We're throwing a lot of money away on this, wasting a lot of effort. Let's just get some tools in place and remotely monitor these sites so we'll know exactly what's going on all the time. And that's really what it's about. You have to ask yourself, what if you could be proactive instead? All this effort you're wasting running around trying to solve things that have already broken. What if you could just be proactive and be maintaining things at just the right minute, going to sites just when you need to, taking care of multiple things in one visit? And that all comes from the intelligence you're going to gain. You're going to know what's failing. You're going to know what your environmentals are doing. What's the temperature? What's the humidity? Know your security status. Is there some theft or vandalism going on? If you know all these things, there's very little that's left to chance. One of my favorite stats was quoted to me. This is a client up in Alaska that we work with, and he's been installing and improving the system that he has over the last 6 years or so. And he's reached a point where he can confidently say that the after-hours call-outs, meaning overtime, late at night, in the middle of the night, when we have to send somebody out to a remote site, those events are down over 75%. So they've cut most of them. And that's just a tremendous advantage when you think about an environment like the one pictured here, where this is eye level. This is just taken with a cell phone for just holding it out in front of you. So clearly this is not a site that you want to have to get into. I've heard of some sites that get snowed in so badly they have a hatch in the ceiling because it takes less effort to dig down to the ceiling than it would to dig down all the way to the door and the wall. So there are some extreme environments where our equipment is used, and clearly if you're reducing truck rolls, that's very important. But even if you don't deal with snow, you're probably still talking about hours of driving time, and we can cut that out. So a little schedule for today's presentation. I want to cover 5 major areas. First thing is, what are the common problems that eat your profits? I hope this is the part that gets you nodding yes, that's me. We've experienced those, and that'll be really good to make sure we're all on the same page. Then the second, of course, is, okay, if those problems exist, how do we solve them? Third, what are your colleagues in the industry doing? We have clients from around the world, mostly concentrated in the United States. I'm going to pull together a lot of their insights in the slides coming up, and you're going to learn the techniques that they use to be able to solve some of these problems specifically, and I hope that you'll benefit from that. The fourth thing, there's one big pitfall that I want you to avoid, and so I'll explain what that is and explain how you can avoid it and why it can be such a sneaky problem, one that catches up with you even though you didn't anticipate it. And then the fifth thing, I'll leave you with an all too common buying pattern that DPS and probably other vendors in our space see, that you don't want to have that happen to you. It's a human psychology thing. We understand why it happens, but if you can avoid it, you'll really be ahead of the game. All right, let's dive right in. What eats your profits? There are 4 major categories I want to talk about, and then I'll break down each one. The first is poor and inefficient infrastructure maintenance. Both of those are important, and I will talk about both parts there. Equipment damage, service affecting outages, and wasteful power consumption. So first, let's take a look at poor and inefficient infrastructure maintenance. There are many ways that this can happen, and there's, as I said, both the poor and the inefficient are important pieces here. It would be inefficient to do the first thing on the list. You visit sites early just in case. So if you don't have good intelligence, you don't know what's going on at a remote site, just go out there more often. That would be the more careful approach to solving the I don't know what's going on at my site problem. But it's inefficient. You're wasting time. You go out more than you need to. The fuel tank's not empty yet. The filter's not needing to be replaced yet, but you're going out there and you're going out there. You're just spending a lot of time driving, and all of that costs money and burns time that could be spent on other things. So that's one potential problem. Conversely, if you are less careful and you just go out when you know there's a problem, you're probably not going out to sites until it's too late because you don't have a good monitoring system to tell you this is coming up. You've reached 90% of your anticipated life. It's time to go out to the site and check on these things. You just wait until there's actually a problem. So you're allowing the failure to notify you, and you should really get some kind of advanced alert that either performance is degrading. It could just be a simple hour count. Hey, we've had a certain amount of runtime. We need to go out and do generator maintenance. Whatever that is, the system should tell you. You shouldn't have to be able to forget in this way and then have it be too late. Number 3, you don't send the right tools or parts or people. This is a question of having a monitoring system perhaps that doesn't give you enough detail. So you know that there's an alarm. Okay, it's a major alarm. But what does that actually mean? So you don't send the right person, or maybe they get out there after a 2-hour drive and they realize, oh, I need this part. Okay, back to the office. We're at 4 hours now, 2 hours back, 2 hours back to the office after you do it. Now you talked about a whole day for a problem that should have been solved the first time. So that's a big concern, being able to send different alerts to different people. And when they get that alert, it should tell them, here's the problem. It's a generator issue. There's low fuel, or it's a certain card is failed on one of my devices. So I need to take a replacement spare part. Whatever that is, you need to know before you leave the office. And then finally, once you're out there, if you have a new problem come in, you should be able to know that. You get an alert on your phone, or an email comes in, or something that you get, the dispatch center calls you. You're being told before you return what the alarms are, so you can knock out a few of them on one trip instead of always coming back to the central office. Next up is equipment damage. This can take a couple different forms. The first one is that you don't notice that the site's overheating. There could even be a fire, and that can lead to a lot of damage just due to thermal energy. The second is similar, but it's dealing in voltage. And so say if your generator's malfunctioning or your batteries are running low, you might have an undervoltage situation. Theoretically, you could have an overvoltage too. And it's just a case of the equipment that you're powering is running outside of its ideal voltage range. And over time, that can either shorten the life or even just kill a piece of equipment. So that can be a big problem. And if you're monitoring voltages, you'll see that happening before it becomes a problem. Number 3, you can't stop theft or vandalism because you don't have door sensors or motion sensors, things that would detect people who shouldn't be there intruding into your site. And then finally, you short cycle HVAC or generators just until they die. You shorten their useful life because you're not using the kind of remote monitoring and analysis that's available to you. So you run them again and again and again when you should run them for longer cycles and a fewer number of cycles, because that reduces the overall wear and tear as opposed to turning them off, turning them on, turning them off, turning them on. That is what kills HVAC and generators. The third cause of losses that eat away at your profits are service-affecting outages. And that can take a couple forms too. Your customers can leave you for a competitor. If you're in a competitive industry, it doesn't take much, especially nowadays with the internet available and people posting reviews and just having an ability to do research on your competition. It doesn't take a whole lot to upset them before they leave if you have unreliable service. Even if you're not dealing in a competitive industry, there's probably something that's encouraging you to provide good service. You may have to pay a contractual penalty if you have a service level agreement with one of your business customers, say, and you have to maintain 99.99, some number of nines reliability. If you don't do that, you have to pay back an advance amount of a premium they were paying, or maybe you have to even pay a penalty. So those can be a big problem. And then if you're working in like a public sector and you've been given a monopoly by the government over, say, power utility space, you're going to have to pay some kind of a fine if you have service go down for more than a insubstantial period of time. So that can be another source of just money leaving the organization when it really shouldn't. If you had better monitoring, you could get things back online and everybody would be happier, including you. And the fourth profit-eating factor is HVAC power waste. And that can come in a lot of forms. I am really interested in this kind of analysis. I think it's really cool. And so I'll break down for you how you can analyze different aspects. But the sources of waste are, number 1, you start cooling at a lower temperature than necessary, meaning your equipment could go and survive at a much warmer temperature, but maybe you set it so that a human would be comfortable. But humans are rarely there, so that's a silly thing to do. And with analysis, we can point out where those opportunities are to increase the temperature. And actually, a smart system, you can incorporate, hey, someone's at the site, let's cool it off a little bit. So we can treat the humans the way they need to be treated, and we can also save power when most of the time no one is at the site. Number 2, you have a wider cooling window than necessary to prevent short cycling, and that's where the analysis comes in, because with HVAC there are 2 factors that fight each other. You want to have long enough cycles so you don't cycle on and off all the time, but you want to have short cycles, short windows, so that you're able to not be fighting a really low temperature, because the farther you push the temperature down, the more energy it has trying to rise back up, and that deals with Newton's law of cooling, and I'll explain that here in a little bit. And then number 3, if your HVAC units have clogged filters or just poor cooling output, they're just not doing their job cooling, that can be a waste, because now you're running them longer to get the same job done, when a simple fix, a little bit of maintenance, replacing a filter, would have solved the problem and get them running at optimal performance. So knowing about all these problems, how do you avoid them? There are 4 major ways, and I'll walk you through each one. The first is you want to collect data from all reasonable sources. The keyword there is reasonable, and I'll get into that. Second, you then take what you've learned from collecting all that data and distribute alarm detail promptly to the right people. Third, you can even program automatic responses so your system will actually do some things instantly, so it doesn't even have to wait for a human to respond. And then finally, you can log and analyze useful data to find more and more opportunities to be more efficient. And before I dive right into each of those 4, I do want to cover some basic monitoring architecture. This would be true no matter which manufacturer you choose. I took one of DPS's app drawings and made it generic by just labeling things RTU and master. and I'll walk you through what that means now. So remote monitoring really starts with RTUs, which is the lower portion of this diagram, and they're going to take in physical inputs and outputs. So this is contact closures or discrete inputs from equipment or from a sensor. They can also do analog, say voltages or current coming in from a temperature sensor or humidity sensor or something like that. And then there's also protocol inputs and outputs, which are not physical, but rather serial protocols or network-based protocols, being able to take in Modbus or SNMP, even some legacy type protocols, bringing those into the RTU so it can understand that kind of information. And then RTUs, if you have maybe 10 or 12 of them or less, you can just use direct notifications. Send an email, send a text message. You're done. You just manage them all, set them all up. They usually nowadays will have a web interface. So get them all set up, send out notifications, and you're set. But if you have more than those 10 or 12 sites, that's going to get pretty ungainly pretty quickly. You're going to have dozens of icons on your desktop to access each one's web interface. That's just not a good system. So what you'll want at that stage is some kind of an aggregator. You might have an SNMP manager that you like. You might want to put in a master station, the one depicted here that's named master. That's our TMON master station. And with a master, you want to make sure that it can take in whatever protocols you need from whatever equipment you want to cover, because that can collect direct, say, SNMP traps from devices. It can also be polling your RTUs and collecting all the information that they've collected. But the key point about a master is it brings it all into one place. And you'll see up on the top of that diagram, you might have a map view web interface where you can go in and you can see the stacks. There's multiple users should be supported. So you can have one up on your big screen, up on the projector. You can have several people at their workstations checking out different parts of the network at different times. So a master brings it all together, so you don't have to be looking at each individual RTU. And then protocols and transport, that's just how pieces communicate to one another. SNMP is a very common telecom management protocol. It's simple network management protocol. You can also see DNP3 or Modbus. Just depends on the devices. But with protocols, just as with, say, human languages, the only thing that's important is that we can understand each other. So if you have one type of protocol coming out of one device, you're going to have some way to accept that through your master or translate it before it gets there so that everything can talk. Because you definitely want to have one unified system. You don't want to have multiples of these different kinds of systems. All right, so let's break down collect alarms from all reasonable sources. You want to, number one, monitor your equipment alarms. So if you have devices that will latch a contact closure or perhaps send an SNMP trap, do something to let you know, hey, I've got a problem, something's a little unusual, or even just, I'm the generator and I'm running right now, just status information. You want to pull that in. You also want to monitor your consumables, things like fuel, that the tank is going to go empty after a while, filters are going to get clogged, anything that needs to be replaced every once in a while. You want to monitor those so you can react to them actually as they need to be replaced and not replace them too often, which I talked about earlier, or wait until there's a failure or you run out of fuel or the filter is completely clogged, because now it's too late. Now you're wasting in a different way. Third, you want to monitor environmentals. This can be a temperature sensor, humidity sensor, security like doors in motion, just what's going on physically around your equipment, because that's immensely important. If you don't know what's going on with that, things can really brew in a way that by the time the first piece of equipment fails, you're in a lot of trouble. And if it's going to take you a couple hours to get to the site, the pain might just be starting, because by the time you get out there, it could be even worse. And then finally, details and clear instructions into your alerts. Even if you have brand new staff, they should be able to look at the alert message they got, whether it's on their phone, in an email, up on a screen, and know what to do. If it's a tower light alarm, okay, you need to call the FAA and report it so they can put it in a notice to airmen. If it's a fuel, here's the fuel company, send out a truck, or if we have our own team, send them out. So you need to be able to build instructions so that the intelligence, all the business rules that you want to use to manage your infrastructure is in the system, and it's not just in the brain of that one person who's been working there for a long time and maybe this person's about to retire. You want everything, all your knowledge to be contained in your management system, so it really doesn't matter who's working, they can react appropriately. I did say reasonable on this slide because there does become a point where, okay, some things just, you can't justify monitoring them. It's either almost never going to be a problem or the sensor required is very expensive. You do have to balance, what am I collecting versus how am I going to use it? And some things are just beyond what's reasonable. But overall, I think your bias should be to incorporate things into your monitoring system. So in this thread, what kinds of things do people monitor? I've actually collected a few bullet points from different presentations I've done with our clients at various trade shows, and I wanted to show you some now. Negative 48 volt power is a common one at sites that use that voltage, but just your power voltage overall, monitoring that. Fuel levels. If you want to set some thresholds that tell you what your fuel is doing and when you want to get alerts, this is one example. If 80% or higher would be considered full, then you can have what we call a minor under alarm trigger at 50% to tell you, okay, the tank is now half empty and it's time to send a truck. And then the major under is at 30%, which is, well, somehow we didn't get the truck out there and now we're at 30% and now it's a bit of an emergency. So you really need to send a truck. So that's an example of being able to set thresholds based on an analog fuel level sensor. You can also have propane gas detectors. This would probably be at a site that has a propane tank, and if it was leaking, you'd certainly want to know that. So a propane gas, kind of a sniffer sensor, is going to let you know about that. And then if you were to get something like 48 volt major from your rectifier, let's say you have a contact closure on your rectifier that says, I've got something wrong with my power, the 48 volt power system, the output's not coming out properly. There might not be a lot of detail, but that alarm alone will tell you you now need to log into the interface of your rectifier. Usually your manufacturer will provide software, or it could be a web interface. You need to get in there and then check it out. So you may not know everything in your base system, but you can have a shortcut built into it. So when you see that alarm, okay, let's log into the rectifier. Let's figure out what's going on. You might also have network time servers that are used to keep everything in sync. So those might put out an SNMP trap if something's gone wrong, and you can pull that into your monitoring system. T1 to IP can also output alarms, that kind of equipment. High and low temperature discretes. These are very simple. This is like a thermostat. You just set it at a temperature. If the temperature goes above this threshold, then latch a relay and let me know about it. That's fundamentally different from an analog because you can't ask what is the temperature. If you set your set point at 85, all you know is it's either above 85 or it's not. And that's important. It's not quite as good as an analog, but it's a very simple thing to set up, and it can be a great start when you're building your monitoring. You can also monitor circuit breakers to see if the circuit is broken, and if that's happening a lot, you can investigate why that's happening. And smoke detectors are also very common. Clearly, a fire is a huge problem at a remote site that you need to know about. So you can have a smoke detector that just latches a relay, ties into your RTU, and then you'll get that alert to say, hey, there's a smoke issue out at the site. For some reason, we're detecting smoke. You can also monitor your generators, and this particular client had a couple contacts coming in. One, is it running or not? And that's useful for just tracking runtime, and is it doing its weekly exercise? Is the oil light on, meaning there's inadequate oil, something's up with the oil in the system? And then what is the current oil pressure? And so that would definitely be that could be discrete actually. That could be, I have low oil pressure. Some generators are going to have Modbus registers that use a protocol to say oil pressure is at this level. And so that would be more specific. But whatever that is, you should know something about your oil pressure if you're using generators. Surge suppressors can also be monitored. So if they are in a state where they've had to offer protection, then you'd want to know about that there was in fact a surge. It's important information. Diesel tanks, again, just like the propane, what's the level? Are they overfilled? Is the fuel down to 50? Maybe we better send a truck. Down at 25%, that's an emergency. Sometimes you can even detect if there's water in the diesel tank, and that's clearly an issue. So you need a sensor to point that out. You can also monitor things like channel banks and other telecom equipment. And this is actually a screenshot that I've magnified of a NetGuardian RTU's menu showing all the discrete alarms that were configured. This particular NetGuardian had, I believe, at least 64 inputs, so it was quite a large RTU. And you can see, starting from the top left, you've got open door, surge suppressor, smoke detector, commercial power failure, low temp, high temp. These are all very typical alarms. You get into things like a dehydrator, which is a little less common. With the low pressure alarm is for that one. You can have 48 volt majors. That's what I mentioned earlier from the rectifier. DC to DC converters, Laris equipment, Spectracom, channel banks, different generator and commercial power alarms. The microwave system. This is a microwave site, so those radios are very important. There's a second page here on the expansion unit. So there's a second RTU shelf that takes in some more discretes. And you can see there's generators coming in there, fuel level, tank leak, water in the fuel tank, and then the strobe and beacon lights on the tower itself to make sure that aircraft can see it, and then generator charger alarms. So a wide variety coming into this set of 64 discrete inputs. And then on the analog side, in this particular application, there's only a need for two analogs. One is fuel level. You can see the current reading is 92.37% in the web interface here. And the 48 volt power is at negative 53. So these are all important little pieces of information that the RTU is collecting. These are the control relay outputs, and this is actually where your RTU can control equipment. So in this case, ID1 is the generator. So if we latch this relay, it's going to tell the generator to fire up. Now, numbers 5 through 8, these are special cases, and this is actually using what we call a derived control to automatically respond to certain conditions. So if there's low fuel or the commercial power fails, we can do different things to the generator and make sure that it activates at the right time. So we don't have to have a human actively watching the screen. The site can take care of itself in certain situations, and it will still report what it's doing, but there's no reason to delay activating the generator when commercial power has failed or when the batteries are low. You know you're going to need it. So that kind of intelligence can be built into an RTU if it's got the smarts for it. Other things that get monitored and controlled, this is from a client up in Alaska, and you can see a site there. It's very snowy, hard to get to. And in this case, there are things like doors, commercial power. He was monitoring generators and fuel levels. A lot of commonality, no matter what industry you're in. Power transfer switches, battery banks, remote weather stations. That's actually a case where if you're going to take a helicopter out to a site, you better be monitoring the weather so you know, can we even land? Because it's worse than wasting or spending the money on a helicopter trip that might be thousands of dollars is getting up there and then not being able to land. So you don't want that to happen. Also out there in Alaska, we've got remote circuit breakers being monitored, some automatic load shedding. So if we're running low on battery backup, well, we can turn off some of the non-essential gear to extend the life of the batteries. Various communications equipment, redundant powered equipment, and then receive signal levels for cell modems and data radios to make sure that all those wireless methods of transmitting data have an appropriate level of signal so that they can be effective. The second point on how we can solve problems and protect your profits, we want to distribute your alarm detail promptly. That takes a couple different forms, but let's walk through a couple. Number one, you want to configure certain alerts for certain people. So that's key. You only want to send, say, security alarms to a security team or forward them to the police department or the sheriff. You might want to send power alarms to a power team. A generator could go to your whoever's in charge of refueling your generators with propane or diesel. That could go to them. Just whatever person needs to get an alert, it should go to that person and not waste everyone else's time. Number two, you want to send alerts directly to staff phones. This deals with not having them return back to the site because they don't know there's an alarm when they were right next to another site and they could have just driven 10 extra minutes and gotten to it. So you can see on the right, I actually have a real world example of some text messages from one of our NetGuardian RTUs. And you can see these have gone straight to a phone, and there's a good amount of detail here. Generator is running. Clear. That means it stopped running. Okay, good. It's clear. Then the Bald Hills door open is clear. That means that door had been opened. That was an alarm, and now the door is closed, so the alarm is cleared. And a channel bank alarm is now in alarm for that third one, and so that's something we might need to go check out. You can see there's a date and time stamp and some other information about the point. So you have good clarity in that plain English description, when if it was some kind of silly ID number, it might be harder for, especially a new staff member, to understand what's going on. And then the third thing is use whatever channel your people need. I said straight to your phones, but that might not be the answer for all situations. If you have staff who are at the office doing dispatch, that might not be right for them. You can send an email, you can send SMS text messages like I've shown here. You can actually broadcast over a radio, which I'll show you in a second. You can have a mobile web interface that people log into. That way they can check alarms, especially if there's a large number. These text messages would pile up pretty quickly if there were a lot of them. So the mobile web interface is a way to filter and just have a better interface for a lot of alarms. And then, of course, a traditional workstation. If you're at a dispatch center and you're at the knock and you're just monitoring alarms, you might want to look at a map on your screen or have a list of alarms. And having that nice big screen, clearly if you're at the office, no reason to be staring at your phone. Why not use the big screen on your desk? And here's an example of a war room display or a map display showing alarm messages being represented as green circles on this map. And everything is green right now, everything's fine. But if there were to be a change, you might see a yellow or a red indicating severity, and then you drill down and you can go from a map like this to maybe a smaller region to a specific building, all the way down to an individual photograph of a rack. And then you could see all your equipment and you could put icons on that equipment. So it just makes it very intuitive. We find that these map type displays make it much easier for people to understand where things are, what needs to be done. When they get out to the site, they look at that photo, they know what kind of equipment they need to work on. Just makes things much clearer than having a list, no matter how good your text descriptions are. I spoke earlier about the direct radio dialer. So this is if you have, say, public safety, you've got some kind of a radio system where people walk around with handheld radios, you can actually render automated text into speech and have it sound an alert, like high temperature at the northwest side, or maybe some kind of security alarm, an incident is happening. Whatever you're monitoring, have it go straight to the people who have the radios on their hip, and then they can respond quickly. It's a variant of our phone dialers, but it's much more immediate because obviously the radio message goes out within a few seconds. The third way that you can protect against these problems that eat your profits is to program automatic responses. I talked a little bit about that when we looked at the control relays screen, but essentially that's two major categories here. You can echo certain alarms to relays or machine-to-machine protocol of some kind. What that means is when alarm A comes in, then trigger relay B somewhere else, so that there's this one-to-one relationship where something happens and we trigger a response, and you just configure those appropriately so that the responses happen at the right moment according to what the alarm is. So low battery, turn on the generator. Number 2 is very much the same here, but it means that we're going to incorporate some logic and we can do some combinations. So we can OR multiple points together. So okay, the same response is valid if 3 different things are happening, so just OR them all together. We only have to use one line and it triggers one relay. Another interesting combination might be, let's say, commercial power failure. We don't need to fire up the generator if there is high battery, because we can just run off our batteries for a while. Conversely, if we have low battery but the commercial power is still on, we don't have to fire up the generator, the commercial power is still on. However, if both of those things occur, we have a low battery and the commercial power is down, we better fire up the generator. So in that case, you would AND those two inputs together so that when they both happen, the response occurs in the form of the relay latch and then the generator turns on. But if one or the other happens, we don't need to respond in that same way. So using that just kind of simple logic, you can set up some surprisingly complex scenarios if you set everything up right, so that your system just automatically responds and it's not always waiting for you and your operators who can get distracted and get busy with other things. The system will take care of itself to a certain degree. Here's a real-world example of that kind of built-in logic and automatic response. So here's a client who had put a power meter on the AC lines feeding a dehydrator, and that power meter would output a 5 volts, actually a 0 to 5 volt signal to the analog input of the RTU. And then you could run logic on that. This client actually did a derived alarm. It was just an alert to say, hey, the dehydrator has been running for over 30 minutes. And if that's the case, not that it just started running, but it's actually been running constantly for 30 minutes, this is something you need to look at, because this dehydrator, I guess, had a tendency to stick on. And if it did that, it could burn itself out. And so this was just an alert to say, hey, it looks like that's happening. You better respond. Do you want to cut the power? Now, derived control would take that to the next level and automatically respond, where when this event triggers and that dehydrator has been running for over 30 minutes, then you could use a control relay and tell it to turn off, or if you have a higher amperage relay, just kill the power. And the fourth and final way that you can solve common problems and improve your profitability is to log and analyze useful data. This is the most long-term. This is where you'd sit down with a report at the end of a month or a year maybe and say, how have I been doing and what are my opportunities for improvement? So 2 examples here. You could look at your HVAC cycling and your temperatures and say, did I set these windows correctly? Do I start cooling at the right temperature? Am I effectively getting down to where I want to stop? And then am I stopping at the right temperature? Should I change these settings, or are these good? Am I happy with the amount of power I'm consuming versus the amount of cycles I'm imposing on my HVAC unit lifespans? Then second, you can also just chart various analog values and discrete counts to see long-term gradual trends. Are we consuming more fuel per unit of runtime, maybe on a generator? Is a certain kind of alarm happening more and more? Maybe it's a sign that a certain piece of equipment is approaching end of life. So by seeing these things spread out across time that might not be obvious in your day-to-day work, you can actually gain some important insights into the overall physics of your network. All right, I want to go a little bit deeper on the HVAC point because this is a kind of monitoring that I think is very interesting, mostly because most problems that would plague your network happen every once in a while. You prepare for them so that every once in a while when disaster strikes, you can respond. HVAC is fundamentally different because other than a unit failure that causes a site overheating that you don't notice, generally it's costing you just a little bit of money every day. It's different. It's not a disaster. It's an ongoing problem with inefficiency. So if we can spot ways to improve your efficiency and reduce the amount of power that you're having to buy to power the cooling system, you potentially could save a lot starting right now and going on forever. So this is a graph showing over time during the course of a day, actually it's about 2.5 hours, a site's temperature rising, which is the red line, and then you'll see the HVAC kicks on as measured by the airflow sensor that we placed over one of the vents. And so that kicks up to 100% to say, okay, the air is now flowing. And then eventually, once the site has been cooled sufficiently, it's going to kick off. That's when the blue line drops down to the bottom again. And then the temperature is going to gradually rise. And then you'll see at 10:45 it happens again. It drops back down when the HVAC turns on, and then it turns off, and now the temperature is going to gradually rise, and so on. And you can see the gaps indicate that in some cases the space between the run cycles is wider, so the HVAC is not running as often. And by looking at this, you can extract a lot of interesting data, and I want to push a little bit deeper into this, so let's move on. Newton's law of cooling is an underappreciated concept among HVAC operators. The rate of change is proportional to the difference between the inside and the outside temperatures. Well, that's all really interesting, but what does that mean exactly? There's an exponential relationship between one object's temperature and the surrounding temperature. So down at the bottom, I explained it a little bit in our context. When it's hot outside, a cold building's temperature is going to rise really fast. But if the building's already fairly warm, that rising rate is going to slow down. So the temperature rises quickly when there's a big difference. Think like a big steam reaction when something cold and something hot meet all at once. It's quite violent and the temperatures equalize quickly. But if they're just a few degrees different, it takes a lot longer for that equalization to happen. And there's a curve that represents this. You can see this is real data, actually. I broke this down, and I think this is really cool. So if you look at the bottom, I've got Fahrenheit temperatures from 70 to 84. So that's what was the temperature at any given moment. And then on the left axis, I have degrees Fahrenheit per hour. So I took all the times when the HVAC was off, and then I said, all right, when it was 70, how fast was the temperature rising? It was allowed to rise because the HVAC wasn't running. What was it? How high was it rising? And it was going at about 24 degrees per hour. So if I just let it sit for that one instance when it was crossing from between 69 and 71 across 70 degrees, it was moving at a pretty good clip at 24 degrees Fahrenheit per second. But then you'll see as we go on, it slows down. And if we jump ahead to say 75 degrees, it was only something like 14 degrees per hour. And then at say 80 degrees, we're at about 11 degrees an hour. And you can see between about 80 and 84, the rate is starting to level off at that very base rate. So it would behoove us, we'd save a lot of power if we can avoid being in the low 70s on this chart, and we can spend more time in the high 70s or into the 80s, whatever our equipment can tolerate. As we shave off degrees, saying let's not go down to 70, let's go to 71 or maybe 72 or even higher, we're going to be saving a lot of money just by shaving those first couple degrees, because that's where the warming is happening the most. This is another version demonstrating the same effect. This is an example of a warming of a room during 1 hour using measured variable warming rates. So the question is, how long is it going to take to rise 2 degrees Fahrenheit? And you can see that when the temperature is lower, when we're down around 71 or 72, it's rising at a faster rate. But the curve starts to level off. So if we can get up into the 73, 75, 77, it takes longer and longer to rise. And what's that going to do? It's going to space out the time between your HVAC cycles, which means overall they run less, they last longer, you consume less power. So it's critical that you look at, can we increase the tolerable temperatures in our sites to, instead of being in the 70s or low 70s, can we get to the high 70s or even into the 80s? The higher you can go, the more you're going to save when it's warm outside, because you're not fighting against those warm temperatures outside trying to keep your site as cool, and you're always going to save money. The same principle is at play in your house. I think everybody knows that if you're Don't demand it to be quite so cool or quite so warm in the winter. You can save a lot on your electricity bill. So the things we're going to be able to calculate by looking at an HVAC log over time, you might send it to DPS, or you might have a device that can do some of this on its own. You are able to calculate that exponential warming rate, and that you are going to reduce your energy use and reduce your HVAC cycle count. You could also separate out, based on looking at different times of the day, hot night versus warm time in the day when the sun is out. We can strip out, well, what is the sun? What is the effect of the sunshine? What is the effect of the air temperature? How about equipment? Even if the temperature is the same inside and out, what is the equipment generating inside the site itself? And that would point us to, can we add shading to the site? Any kind of reflectivity to just fight that solar load? How about, it's probably pretty unusual, but insulation. If we're in a very hot environment and we don't have much heat load inside the site, having a little bit of insulation between the outside and the inside temperature is going to protect us from that outside hot air. You might also spot daily and seasonal heat load changes. I know some telecom networks during the afternoon, if everybody's making phone calls or on their phones, otherwise transmitting data, you can actually see the radio heads increase in heat significantly. So there are those kind of daily business effects. And of course, the sun and just the daily temperatures are going to have an effect. And then seasonally, as the seasons change, how are things changing? Being able to have that and analyze it all, you can really spot a lot of savings. And then you can anticipate your HVAC lifespan if you know that, all right, I'm running at an average of 15 cycles a day instead of 25. And so if you know these kinds of things, you can project the manufacturer rates it for this many cycles, therefore it's going to last for this many years. So that's all stuff you can get just by logging some pretty basic stuff. When does your HVAC turn on? When does it turn off? What's the indoor temperature, outdoor temperature? It really doesn't take a lot, but with the right smarts, you can perform some kind of big data analysis if you find the right manufacturer, and DPS is starting to do some of this stuff. Well, that brings us through the 4 solutions to protect your profits, and I wanted to share a sentiment that one client offered, which was, the further you get with monitoring, the more things you realize that you can monitor and save money. And that's really true. You're going to learn a lot by your first endeavor, and you're going to be able to improve and improve and improve gradually. And you learn what kinds of things you can monitor. Once you have a base system, you can layer new things onto it. So in that spirit, I want to share with you some best practices that some of my clients have told me over the years. Speaking to that need that you're going to grow over time, I heard that if you think you need 16 discrete points, as an example, you actually need 32. And what that means is you want to plan for the future. You want to plan for the idea that what you know you need to monitor today. I know I have 15 discrete points. Having one extra is probably not enough. I might want to think about 24 or 32 or however many are available on a unit I'm considering. And it can be useful maybe to think about your first hard disk capacity. That's what he told me. Do you remember how small that was compared to what kind of storage you have at your disposal today? So consider that things do grow over time. Don't say to yourself, this point isn't that important. Really think, is it reasonable to monitor this point? And you should have a bias towards saying yes. Clearly, some things are just beyond what you need to look at, but most things are important. And after you have an incident, you're going to learn. So that's inevitable. There are going to be mistakes and incidents as you're working with your network. The more things you can nip in the bud and handle early, the better. Monitoring battery analogs, as in voltage, was also a best practice that I hear a lot. And that can just be as simple as having an analog input that the string voltage feeds into. Some RTUs even have the analog circuit internally wired. So just by powering the RTU off of the batteries, you're intrinsically monitoring the voltage because they monitor their own power inputs. Throw most things into your alarm inputs. It's good to just monitor as much as is reasonable. You can overdo it, but, and I quote, the more you monitor, the better you sleep. So if you just have a good picture, you know what's going on. If you're confident, you really will have a better state of mind because you know that your network is taken care of and you haven't dropped the ball anywhere. Now I want to get into some clever solutions for stubborn problems. These are just some specific things that our clients have done, and some of them might inspire you for things that you might be able to do in your network. But even beyond the specifics, just the idea that you can custom tailor things, because monitoring is important and you can justify quite a bit. The cost of a solution is quite small compared to the cost of a problem that it would prevent. So get specific. Work with a vendor that can customize things and get you exactly what you need, because there's a lot of return on investment that can be gotten if you have good monitoring. So let's look at a few specific examples here. Gradual legacy migration. This is a key point. if you have legacy RTUs that are still working, why not keep using them? You got your investment. You don't just want to go out with a forklift one day and rip them all out and buy a bunch of brand new ones. That's silly. You can replace your master because it's probably a single point of failure if you have a legacy master that you're keeping going just because you need it for these RTUs. And then you can gradually transition to new RTUs over time. So I have a little graphic here to show that. So on the top left, in phase 1, the beginning, you would have a legacy master and then legacy RTUs. So the first step, as I said, let's get rid of that legacy master, because if that thing goes down, you lost the whole network. So that's where the bottom right is. Step 2, we've put in an advanced modern master that speaks the protocol that's necessary, and it can still talk to those legacy remotes. And now you have a system that's got a future. And sure, a few of the legacy remotes might fail, but it's nothing like having the master go down. Then in step 3, you're going to, as I say, you're going to have some legacy remotes fail. You can replace them with modern RTUs, but the difference here is now you can do it gradually, maybe a few per year. Just, you could say, okay, in 5 years I want to be fully transitioned, and you can aim to have at least 20% per year, so you could do some when you choose to, others just when they fail. And so you're going to have a transitioning system for a period. And then finally, step 4, once all that's done, you will have a modern master and modern RTUs. And you've done that gradually over several budget cycles. You've had a nice, smooth legacy migration. And good equipment will let you do that. And in this case, it's a multi-protocol master. The DPS Timon speaks a lot of different protocols. The key is just that it speaks modern standards like SNMP or DNP, but also legacy standards for the RTUs that you have in your network that you're trying to transition away from. This one I thought was pretty creative. Some alternatives for generator status monitoring. You can have contact closures from your generator, and modern generators more and more have Modbus registers, but those can theoretically lie. There's nothing that says just because this contact is closed or this Modbus register has a certain value that guarantees that your generator is running. But if it's vibrating, that's a good sign. It must be doing at least something. So you can actually put, like our vibration sensor there off to the right, you could put that on the generator, and I have clients do this, and sometimes it's just a redundant backup. They'll monitor the alarms, but they also want to know, is the thing vibrating, just as a fail-safe. So that's a creative way to use an inexpensive sensor as either a backup or theoretically as your primary way of saying, is my generator running? Especially if you had an old one that really didn't have much in the way of automated reporting. You can just slap a vibration sensor right to the side of it, and it's a pretty good indicator of whether or not the thing's running. And then the third bullet point there at the bottom, I actually talked to one client who used an IP camera, and they'd see the exhaust louvers open, and they'd know that the generator had turned on through that method. It's a little bit unorthodox, but I think that's a really good system. You know, okay, the thing's running because it opened up its exhaust system, so I know that my generator's on. Talked to one client who spoke about holding others accountable. So you might have a third-party vendor who is blaming something else and not what they provide. So in this case, it was a vendor who was saying that the problem was with your propane pressure, and it's not our system. And he basically had to take his word for it. But if he goes to add a pressure sensor to actually detect the propane pressure, he can look at his logs and he can say, no, in fact, I have adequate propane pressure. I'm within your spec, and something's still wrong, so help me out. So you can keep your various partners accountable to make by understanding what really is going on. You don't have to just take someone's word for it. I also talked to some clients about remote temperature control. This was a massive savings in terms of driving time and sending people out on truck rolls. When they first started monitoring, it was just temperatures. And then they got to a stage where they wanted to control it. And then they actually tied in fans where you'd have intake and exhaust to bring in cooler air to get some free cooling. And then the ultimate savings was due to technicians would go out to the site and they'd turn the temp all the way down because it was warm in the site. They wanted to cool it off, so they were going for human comfort. And then they'd come back. But the problem was that was 4 hours away from the office. So we're talking about a whole workday just to get out there and get back. And so now, with automation, they can reset that temperature if the technician forgets to turn it back up without having to send another person out to waste an entire day just to make sure we're not burning more power than we need to. So a good system like a HVAC controller, we actually have one at DPS. You can hit a comfort button, and then for an hour, it's going to notch the temperature down, but it's always going to auto reset. So smart solutions like that, and being able to remotely get in and change the temperature to whatever you want, whenever you want, that's going to save you a lot of wasted trips and a lot of electricity. Airflow monitoring. This one was interesting. This is also way up north. In the fall, I guess, the bugs in the northern parts of the world, they get incredibly thick because they have a very short summer to work with, so they reproduce quickly and they're just prodigious. And in this case, they were actually clogging an air filter. And so a temp or an airflow sensor was handy here because you can sense, is the temperature rising? And is the airflow not flowing? And so you'd know, oops, we can't cool the site. We needed to know that. Now we can get out there and change the filter. So this is a very curious way of Mother Nature striking at a remote site, but temperature and airflow was the solution. And just by monitoring that, you'd know if bugs had clogged up your filter. Next up is monitoring with a fiber-capable RTU, and I didn't put this slide in so much to show you this specific application. I mean, if you need a remote that has SFP sockets so you can use SFP modules and put it on a fiber ring, then that's great. But really, this is a point about getting the exact RTU you need, because your monitoring system is important. You're protecting yourself against big monetary risks, and so you want to make sure that it suits your exact requirements. So if you're not seeing something, whether it's a protocol or a transport in this case, or even a form factor, I need it to mount to the wall or I need it to mount on a DIN rail, call up your manufacturers and ask, because good ones will be able to adjust the design and customize it to suit your need, because this is an important project and really it should fit your requirements. Every network is unique and you should be able to get a good system. This is a similar example, which I don't think you're going to need this unless you happen to be in a very cold climate, but it's another example of something highly customized that we developed just so you can get a sense of the specialization that can be involved in a good monitoring system. So this is propane vaporization management, and I'll give you a bit of a chemistry lesson that I had to be given when I initially started working on this project. So propane in a tank is stored in a liquid form, and then it boils. And it boils well below room temperature, so it's always boiling. You don't have to heat it up artificially, except when you get down way below zero in the Fahrenheit scale, so -20, -30, -40. Now you're going to have issues with boiling. It's not going to vaporize properly, and if it doesn't do that, it can't leave the tank and it can't power whatever generator it's powering. So what we developed here was a balancing system that seeks to maintain tank level at 50%. And the reason for that is you can see in the illustration that the center of a cylindrical tank is the maximum surface area that you're going to get. If it's very near the top or very near the bottom, you don't have a big surface area to work with. And surface area is important because every little bit of surface you have increases the possibility of vaporization. So even as that temperature drops, we're going to get the maximum possible boiling of propane that we can get considering the temperature. And so that's why this controller exists, and all it does is has a little bit of automation that says, well, tank 4 is at 60%, we'd love it to be down at 50%, let's burn a little bit. And then as we hit 50%, well, let's switch over to tank 2 that has 70% and get that down a little bit lower. So we just maximize our surface area to make sure we can get flow into the generator so we can generate electricity when we need it. All right, now as promised, I was going to warn you about a particular danger that people fall into, a minefield, a trap, and we call it the in-house solution stack hack. So I'll explain to you what that is, how people fall victim to it, and how you can avoid it. So what is a solution stack hack that you might want to build yourself? It's multiple pieces of gear kind of mashed together in your own unique configuration. You have some homebrew integration elements. So maybe you bought one thing from Amazon and you had another thing that was a legacy piece of equipment, and you got something else from your network system provider, and now you've got all these pieces, but you build some cables, you have certain power adjustments, you program a special script that's going to cause things to work together. So you've created some glue to hold this little homebrew solution, your solution stack together. And only you understand it, only you can support it. It seemed like a good idea at the beginning, and honestly it was. So let's take a look at how things evolve. We're going to look at how they originate, why they're actually important to your company's performance, and why they always will eventually fail. There are just some critical flaws in that system, and how you can fix that process and actually get a good result. So really with solution stack hacks, we're asking the question, how does a good idea, I'm going to make a lovely little robot, how does that become a horror story? And let's break it down. Things start, you are going to be tempted to do an in-house solution stack hack for one of these 4 reasons in almost all cases. One is a recurring problem. So like the hamster on the wheel there, you're feeling like, boy, haven't we seen this before? I need to fix this, and you take it onto your shoulders. Workarounds and adaptation. You've got a problem, some new piece of equipment has come along, there's no manufacturer support maybe for a piece of legacy gear, and you have to come up with a way to make it work in the modern world. So you create workarounds, you adapt, good intentions, and you create some kind of solution that's going to help you get around that problem. Anything repetitive where you need automation, maybe a testing tool, just something that happens a lot where you're trying to be more efficient by building a tool that's going to speed things up. And then also information sharing and logging. You need to keep a record. You need to pass data to another department. That may involve some programming and some creative engineering on your part to make that kind of communication and storage happen. So at the beginning, it's just you. You're the technician. You build it. You're in the center of that bullseye diagram there. And then it goes out to one site once you deploy it. And at this point, it's very manageable. And then pretty soon it goes out to a small region perhaps. Now you've got it at 5 or 10 sites. And at that stage, it's small enough that just you and maybe your manager, maybe a couple coworkers, you're handling the problem. It's only at a small region that you're responsible for, and you're in pretty good shape. Things are looking good. But the larger that impact horizon is, you spread out to a large region or even your entire company, you're going to encounter more friction. There's more difficulty, and let's look at what some of those things are. In-house solution stack hacks are difficult to scale, primarily because you can't guarantee that you're going to be able to purchase the individual components. You're not a manufacturer. You're just a guy who bought a couple of things. And if a manufacturer of one of the parts decides to change the version because, well, nobody ever uses that feature, we're going to eliminate it. Maybe that's critical to your application and they don't know it. They don't know that you're using it for this particular purpose. So those kinds of things can happen. Devices can be entirely just manufactured discontinued, and now you have no solution. So that can be a big issue. Also, when you and a small team are working with your solution stack, you don't need a lot of documentation, but as it rolls out to more and more departments, if you're a big company, there are going to be people asking a lot of questions and we're going to be confused in ways that you never were because you created the thing. So that becomes a big issue. You're having to support them. And you can end up being squandered, really. Your whole job can become supporting this silly thing as it rolls out. So your stress can soar up, job roles are going to change, and having to clean up these problems can really be a huge nightmare sometimes. And when the solution starts to work, that's when the hairs on the back of your neck should stand up, because that's when the trouble can start. Like I said, when you have a single site, you can handle everything. But when it goes to a small region, you can maybe have a small guide, and okay, that's going to work all right. But as we expand and we expand and we expand, it's going to just become a full-time job. You're going to be consumed by this thing. You're going to have to build a better setup guide. You're going to have feature creep, because people are going to say, what if it did this? What if it did that? Okay, well, I'm a well-meaning employee. I'm going to try to do that. You just get buried in these kind of requests. And ultimately, a solution stack hack is a bit like the easy bake oven there. It's not a professional solution in most cases. You just don't have the resources or the time to devote to this. This isn't your entire job. It's a very small fraction of your job. So if you're going to be building something, you might want to consider working with a partner who's going to be able to make you a really good professional solution, because it's all they do. They're a dedicated company. And ultimately, you're going to save money. It might seem at the beginning that, if I do the solution stack, it's going to be worthwhile. It's going to save us money in the long run because we don't have to pay that nasty vendor something. Consider the full impact. Certainly doing a little basic prototype for yourself is fine, but the kinds of things that you get from a dedicated vendor, like support, like being able to have a good document, a full user manual right from the beginning, that's very important. They're going to guarantee parts availability. They know how you're using it, so they're going to make sure that they don't engineer out a feature that you need. Just having a professional solution is much superior than trying to homebrew something yourself. Same example here, a little scooter versus a motorcycle. And my favorite here, the pathetic garden hose versus the powerful fire hose that takes multiple people to hold it to prevent from being blown back. And lastly here, I want to leave you with an all too common buying pattern we see, because I see this happen so much. I really try to explain to people that this happens, but the way organizations work, I understand. We do it here sometimes too with problems that we need to solve. Just walk with me through these 5 steps. you have an initial incident. In the case of remote monitoring, it's going to be something that went wrong, whether a generator ran out of fuel, site went dark, somebody called in angry, whatever that is. You should have known about it. You didn't. You had an incident. So then you solicit proposals in a flurry of action. Hey, vendors, send us what you got. This is our problem. And you get some number of them who reply. Well, like everything, monitoring isn't the only thing you do. It's a very small fraction of what you do. And so you get busy. You have to work somewhere else. And so your focus is going to shift. The pain fades over time. Your boss might lose interest, even though he may have been very angry at the beginning. And so focus shifts, and that's understandable. Inevitably, though, because you didn't fix it, you're going to have another incident. And that's when most people will then buckle down, and hopefully it's still you. Sometimes these incidents can be so big that there's a bit of house cleaning that goes on. But ideally, you're going to be there and you're going to be able to solve the problem. And now everybody who's on that team is going to be laser focused on getting it solved. But I would advise you, if you can avoid that, do it. If you can short circuit this process and just fix it the first time, that would be good. So I encourage you, no matter what your relationship is to remote monitoring, if you know you have some kind of a problem with your monitoring, if you're not getting total visibility of remote sites, you recognize you have an issue, act before you have that second preventable incident. If the first time something happens, take it as a sign you need to get this solved. And if you're really fancy, see if you can't get out ahead of the problem before it even happens by taking some of the advice that I've shared with you today. My name is Andrew Erickson. Again, I work for DPS Telecom, and my phone number here, if you want to call, 1-800-693-0351. I really do answer the phones. If you talk to anybody in sales, though, they'll be able to help you. You can check us out on Twitter at dpstele.com as well, or visit us on the web at dpstele.com.